The Atterberg Limits test references ASTM D4318. This test helps in discerning between silt and clay. It describes a soil state with moisture content, primarily. If the moisture content of a soil is very low compared to optimum, it is considered a brittle solid. The main goal for the test is to determine the plastic limit, liquid limit, and the plastic index, which is the range between the plastic limit and liquid limit. The plastic limit is defined as the water content of soil between the semi-solid state and the plastic state. The liquid limit is defined as the water content of soil between the plastic state and the liquid or viscous state. The plastic index is the range of water contents over which a soil behaves plastically. As mentioned before, the Atterberg Limits test determines the liquid limit, plastic limit, and the plastic index of soils. Numerically, the plastic index is equal to the liquid limit minus the plastic limit. The plastic limit indicates how plastic our sample soil is. Low values of plastic index indicate low plasticity. High values of plastic index indicate high plasticity. The plastic index and the liquid limit is finally compared, and the soil can then be generally classified as silt or clay. Before we get started with the test, we must introduce a few tools used. First, the Casagrande grooving tool will be used, primarily for the liquid limit test. It has a unit depth and a unit width to make a groove in the soil. Next, the spatula. Next, the Casagrande cup. The Casagrande cup is primarily used to determine the liquid limit. Then we have the grass ground plate. The grass ground plate is primarily used to determine the plastic limit. It allows us to wick moisture away from the sample, bringing it to its semi-solid state. Finally, we have the mortar and pestle. This is used to crush silts and more friable soils. In preparing for the Atterberg Limits test, we need to retrieve an air-dried or oven-dried sample and sieve it through the number 40 sieve. We must retain 150 to 200 grams that passes the number 40 sieve. Once the 150 gram to 200 gram sample is obtained, the sample is ready to be moisturized with de-aired water. Moisturize the sample slowly with a squirt bottle and mix with a spatula until the soil is consistent and thoroughly mixed. Moisturized material is about the consistency of peanut butter or thicker. Once the sample is thoroughly mixed, the material is adequately covered so that the soil particles are allowed to moisturize for 16 hours. After 16 hours, the material will be ready for the plastic limit portion of the test. Just a quick overview of the definition of plastic limit relative to the test. The plastic limit is defined as when the soil can no longer be rolled or pressed after it has become a 1/8 of an inch thread. At this point, the soil is considered to be between its semi-solid and plastic states. We will use the glass ground plate to wick moisture away from the sample to achieve this soil state. After 16 hours of soaking, the plastic limit test is ready to begin. Uncover the soil sample, remix the soaked soil to ensure consistency. Re-roll the soil into 1 to 2 gram balls. Make 5 of these balls. Next, begin to roll the balls into 1/8 of an inch threads against a glass ground plate. Allow the soil to break up so that it would become between its semi-solid and its plastic state. If the soil thread does not break apart, or crumble, re-roll the ball and continue rolling until this occurs. If need be, re-roll the same thread multiple times. Obtain at least 6 raw grams of soil in 2 separate containers, i.e. do 2 separate trials. We will average the moisture content of the 2 trials. Weigh the tare and the wet soil and record these values. Oven dry the 2 samples at 110 degrees Celsius to achieve a consistent moisture content. Back to our definitions. We will now focus on the second definition listed here. The liquid limit is defined as the moisture content at which exactly 25 blows is recorded to close a 13 mm standard groove that has been cut into smooth soil in the Casagrande cup. At this point, the soil is considered to be viscous or at its liquid state. This is the transition between the plastic and liquid states. The end result of the liquid limit test should look something like this. We will attempt 3 trials and fit a linear line to the 3 data points so that a moisture content corresponding to a blow count of 25 can be extrapolated. The goal is to first obtain a moisture content within the 30 to 35 blow count range, then the 25 to 30 blow count range, and finally the 20 to 25 blow count range. Corresponding moisture contents will be achieved. Then the plot moisture content as a function of blow counts. Linearly fit a line through the dataset and extrapolate the moisture content on the fitted line that corresponds to 25 blows. This is known as the liquid limit. Use the same mixed soil as we had previously used for the plastic limit test. Uncover and remix the soil thoroughly and add water if need be. If additional water is added, be sure and mix thoroughly to achieve a consistent sample. Transfer a couple of grams from the mixing bowl to the Casagrande cup. Smooth the sample in the cup. Make sure the surface is smooth and the soil is flat across the cup relative to the front of the cup. Next, use the standard grooving tool to cut a groove in the smooth soil. Make sure the groove separates the soil. Turn on or turn the crank, keeping track of the number of blows. Once a 13 mm gap has closed, stop the crank. 13 mm gap is approximately the standard width of a spatula. Cut the soil out with the spatula and transfer into a tin. Weigh the tare, then weigh the wet soil, the tare, and oven dry this sample at 110 degrees Celsius. Try and achieve the first trial between 30 and 35 blows. Moisturize the soil and mix. Repeat the process trying to obtain 25 to 30 blows. Repeat the process one last time to achieve blow counts in the range of 20 to 25. Oven dry samples. Once the samples have dried, weigh and record the tare plus the dry soil. Average the 2 moisture contents for the plastic limit portion of the test. Obtain 3 separate moisture contents for the liquid limit trials. There should be 3 of them. For the data reduction section, we will first analyze the liquid limit results. This is an Atterberg worksheet. Here's a table with trials in the left-hand side column, then the moisture content corresponding to the trial number, and finally blow counts that also correspond to the same trial number. We will plot these results to extrapolate our liquid limit. Here's the plot of moisture content as a function of blow counts. Notice that a linear fit has been graphed through the raw data set. Draw a vertical line at the 25 blow tick mark. The line should extend to the linear fit line. With the perpendicular intersection of this vertical line, a moisture content will be read off. This moisture content is the liquid limit, i.e. the moisture content at which the soil is considered to be at its liquid state. Here are the final results. Recall that the plastic limit was the average moisture content of the 2 plastic limit trials. The plastic limit was equal to 20.08%. The liquid limit was equal to 33.5%. The plastic index, which is the liquid limit minus the plastic limit, comes out to approximately 13.42%. This puts our test soil in the medium plastic range. which is typical for kaolin clay. Casagrande's plasticity chart allows us to classify our fine-grained soil based on its plasticity. As we can see, plasticity index is plotted on the y-axis and liquid limit is plotted on the x-axis. With the plasticity index and liquid limit we just found, we place its point on the graph. It will land in a classification region. These classification regions are generally characterized by the A-line. The A-line is the bottom of the two linear lines. A point on the A-line and above is classified as clay. A point below the A-line is classified as silt. As we work our way up the linear line, plasticities go from low to high. In our case, a plasticity index of 13.4% and a liquid limit of 33.5% lands us in the low plasticity clay region. This is a typical classification for kaolin clay. This concludes the procedures and data reduction section for Atterberg limits.